This is lesson 514, trigonometric applications. So we already know all the math that we need for this lesson. We're just going to be applying it to some word problems. David and Emily are climbing El Capitan, a big cliff wall in Yosemite National Park. David is on the ground holding the rope attached to a pulley above Emily as she climbs. So maybe David's over here and he's holding this rope that's attached to a pulley that holds Emily as she climbs. So maybe that's like Emily right down there. Okay, so maybe that's Emily. And then when Emily stops to rest, David is wondering how high she has climbed. The rope is attached to his waist, which is 3 feet above the ground. So here's the ground right here. And he has let out 48 feet of rope. So from like here to here, that's 48 feet of rope. And David is standing 20 feet away from the base of the wall. So that's 20 feet. And this is the rest of the wall here. And the rope at his waist is making a 55-degree angle. So we don't know how far up the base of this wall Emily is. So that's why I just put that there. But the pulley's up here, David's over here. And that's the information we have right now. So how long is the rope between David and the pulley? Okay, we know the total rope was 48 feet, right? But we don't know the length of the rope between just David right over here and the pulley up here. So we have that this is 55 degrees and that the base of this triangle is 20. So if we're looking for the length of that rope just between the pulley and David, we could use cosine because this is the adjacent side and the hypotenuse side. So cosine of 55 is equal to adjacent over hypotenuse, so 20 over x. We can cross multiply and get the cosine of 55 times x equals 20. And then we can divide both sides by the cosine of 55. Divide by the cosine of 55. And we're going to end up getting 34.87. So the length of that side of the triangle is 34.87, right there. And then how far is Emily from the pulley? I think we can kind of answer that by finding how high up the wall has she climbed. Those two kind of questions we can answer with the same picture. So I'm going to redraw our picture over here. I'm going to move this over. So Emily's somewhere over here. Here's the pulley. We just found out this was 34.87, 55, and then we knew that was 20. Okay. Let's find this side of the wall. So this would be from the base of the cliff, or actually from 3 feet up the cliff to the pulley. So that would be the tangent of 55, I'm going to call that y there, would be equal to y over 20. Going to cross multiply, and tangent of 55 times 20 gets us 28.56. Okay, so that entire wall is 28.56. Now, how high up the wall has Emily climbed? Okay, maybe we should figure out this distance right here from the pulley to Emily, I'm going to do that in a different color. This distance right here from the pulley to where we think Emily is. We knew that the rope is 48 long, right? And that goes all the way down to Emily. So maybe what we can do is we know this much of the rope is 34.87. So let's subtract that away real quick from the total 48. And that's going to get us 13.13. So that means from the pulley down to Emily, there is 13.13 feet of rope, okay? So Emily is 13.13 feet away from the pulley. And then we can continue that by going, okay, what's the rest of this distance from Emily down to the bottom, right? We found out the entire thing was 28.56, that entire side. So we're going to take that, 28.56, and subtract away this 13.13 that we got. And that gets us 15.43. That distance right there. Emily from the bottom of our triangle. However, we can't forget the fact that David, that rope is 3 feet off the ground. So we're going to need to take this number, add 3 to it, and then we get 18.43. Emily is 18.43 feet above the ground. All right. Moving on to a much easier question. We have a circus tent. The pole to hold up a circus tent is 70 feet tall. A support cable needs to be attached to it so that it forms a 60-degree angle with the ground. So 60-degree angle with the ground. Here's the support pole. Here is support cable. We've got the circus tent pole here, and that's 70 feet tall. So here's our picture. And how long is the cable? We can use this solving simple trigonometry. 60 degrees, 70 feet. We want to know that side. So this is our opposite side, hypotenuse, so that's going to be sine. 60 is equal to our opposite over hypotenuse, so 70 over x. We can cross multiply and get sine of 60 times x equals 70. Divide both sides by sine of 60. And we're going to get that x is 80.83. And then how far from the pole should the cable be attached to the ground? Okay, so that means now we are looking for this side. I'm going to call that y. This is still 70. This is still 60. So this is the adjacent side, and this is the opposite side, which means we're going to be using tangent, okay? So tangent of 60 is opposite over adjacent, so 70 over y. We can cross multiply the tangent of 60 times x equals 70. Divide both sides by the tangent of 60. Running out of room there. So 70 divided by the tangent of 60, that is going to get us 40.41. Okay, and that is, oh, and I'm sorry, that is y, isn't that? So that's right there. All right, moving back to this kind of mountain climbing problem. Apparently now we have Nathan standing in a meadow exactly 185 feet from the base of El Capitan, and at 11 a.m. he notices Emily climbing up the wall and determines that his angle of sight up to Emily's 10 degrees. So we're going to draw a picture. So here's Nathan. He is looking up at Emily, climbing the wall. Here's Emily. He's looking up at her, and that's making a 10-degree angle looking up, okay? And we know that he's standing 185 feet away from the base of El Capitan. So his eyes are 6 feet above the ground. So that's going to be 6. Approximately how, I think that should say how high is Emily at 11 a.m. So we could kind of go ahead and redraw this triangle. 10 degrees. Here's Emily up here. Here's Nathan's eyes down here. And just keeping in mind that that is 6 feet above the ground. We'll have to add 6 feet at the end. But we could go ahead and find how high Emily is right there. So that is, oh, and then we know this is 185. So we've got opposite side, adjacent side, so this is going to be a tangent problem. Tangent of 10 is going to be opposite over adjacent, so x over 185. And when we cross multiply, that's going to be 32.62. But then remember, Nathan's eyes are 6 feet above the ground, which means we have to add 6 to that. So that's going to be 38.62. She is 38.62 feet above the ground at 11 a.m. At 11:30, so half an hour later, she's climbed some more, and now his angle of sight is 25 degrees. How far has she climbed in the past 30 minutes? So now we've got 25. We're not sure how far she's climbed. He's still standing 185 feet away. So this is still a tangent. The only thing that's different is the degree. Okay. So that ends up being 92.27 right there. And again, remember, she's 6 feet above the ground, so we're going to add 6 feet to that. Oh, I'm sorry. This is 86.27 right here. 86.27. And when we add 6, that gets us 92.27. Okay, so that's how far she is. But look at the way they worded this question. How far has she climbed in the past 30 minutes? So what we need to do is we need to take this number, how far she had climbed at 11, and subtract that from this number, how high she is at 11:30. So 92.21 minus 38.62, that is going to get us, let's see, 92.21 minus 38.62, that's going to get us 53.59. So she has climbed 53.59 feet in the past 30 minutes. In past 30 minutes. And believe it or not, we have more questions to ask about this problem. If she climbs 32 feet higher in 10 more minutes, what angle will Nathan have to look in order to see Emily? All right, so keeping in mind that at this point, this was 82.27, and she's climbed 32 feet more than that. So 82.27, that was the side of our triangle. She's climbing 32 more feet. This side of the triangle is going to be 114.27. He's still 85 feet away from the base, 185. And this time we don't know the angle. So this is going to be inverse tangent, okay? Of 114, or I'm sorry. Yep, 114.27 over 185. And if we type that into our calculators, we get 31.7. So that angle, he has to look up 31.7 degrees to see her. All right, moving on to our last problem. How much paint do I need? So we need to repaint the side of the house because it's peeling. Each can of paint states it will cover 150 square feet. How many cans of paint should we buy? Now, unfortunately, all of these measurements are in meters, so we'll have to keep in mind that we'll have to change that to square feet in order to calculate for the paint. But in this shape, looks like we kind of have a triangle and a rectangle here. And then one thing we know about a four-sided shape, the angles add up to 360. So if this is 90, 90, 126, that means this angle right here is going to be 54. So let's go ahead and draw out these two shapes separately. So 54, we know this is 9, we don't know this or this, and then the rectangle below it, we know this is 8, and we don't know what that other side is. So why don't we just start finding some missing sides of the triangle. Let's call this X and Y. So first I'm going to find X. This is the opposite, adjacent, and hypotenuse of 54. So to find X, I'm going to do sine of 54 equals X over 9. And that is going to get me 7.28. So this bottom side is 7.28. And then for Y, this is going to be cosine of 54 is Y over 9, which means that Y is 5.29. And here, 7.28, these are the same side, right? So that means on the rectangle, this is also 7.28 here. So now we have everything we need to find area. The area of a rectangle is just base times height. So 8 times 7.28, that's going to be 58.24. And then the area of a triangle is base times height divided by 2. So that's 7.28 times 5.29 divided by 2, which is going to get us 19.26. So these are the areas of them separately. We can go ahead and add those together. So 19.26 plus 58.24. That gets us a total of 77.5. But that's in meters, right? And we have that 1 square meter is about 10.764 square feet. So what we need to do is take that and multiply by 10.764. And that gets us 834.16. So now we're in feet. That's how much area we have, right? That's the total area. And we have that 1 can of paint will cover 150. So we want to see how many cans of paint we need. Let's take this and divide by 150. So 834.16 divided by 150. That equals 5.56 cans of paint. However, can you buy 5 and basically a half cans of paint? No, you have to buy whole cans of paint. So this will be 6 cans of paint that we'll need to buy. And that is what we have for word problems.